Formula sheet applications. Our objectives are to be able to use the formula sheet to identify figures and determine the area and volume of two-dimensional and three-dimensional figures, including practical problems. Let's talk about when we need to find something that's missing first, before we can apply the formula sheet. For example, a TP in the shape of a right cone is made with waterproof material. If the material is used for everything except the floor, approximately how many square meters of material will be needed? So notice they didn't say anything like find the area, find the volume. We have to determine which thing we're going to find by some key words. Often when we look at the units of measure, that can help us. So remember that square units is a measurement for area. What kind of area exactly? Because if we go to our formula sheet to match the cone, here's the cone, we have two different kinds of area, LA and SA, the lateral area and the surface area. Which one? Remember, lateral area means the sides, surface area means everything, the base and the sides, and if there's a top to the figure like a prism, then also the top. Going back to our problem, let's see what words can help us determine which one. So the material is used for everything except the floor. So that means we're not covering the base. So except the floor, not the base. That means we are just covering the sides with the material. So if it's area and it's just the sides, that would mean we are using the lateral area. So back to our formula sheet, for the formula for the lateral area of a cone, we see that the lateral area is pi r L. The r is the length of the radius, and the L is the slant height, the slanted height going down the side of the cone. So let's write down our formula for the lateral area. LA equals pi times r times L. Now in the picture, the r is supposed to be this length right here. Did they give me that length? Doesn't look like it. It says 12 along the bottom, but because the 12 is not in the middle where the r was written in the picture, that means the 12 is not the r. That's the diameter. The diameter of the cone is 12. The diameter is 12 meters. The radius is half of that, because instead of going from the center to the edge, the diameter goes from one end to the other end of the circle all the way across. So the radius is half of the diameter. So half of 12 equals 6. The radius is 6 meters. Let's label our picture with 6. Now we also need the L. The L is this length along the side of the cone, not the height going straight up and down. That's labeled H in our formula sheet. How do we find that? Well, notice that that is part of this right triangle. I'm going to trace this right triangle in red, and you'll notice that I have one length is 9, one length is 6, and the length that I need we don't know yet. How can I find that length? Well, let's look all around our formula sheet. If we look on the back of the formula sheet, we're reminded of the Pythagorean Theorem that relates the sides of a right triangle. Let's use this to find our missing length, because what we have is that this length is 9, this length is 6, and this length is what's missing. That's the L. So back to our notes, we can remind ourselves that we can use the Pythagorean Theorem for the lengths of the right triangle. This length, like we wrote, is 9, this bottom length 6, and this length L. Now on the formula sheet, it's written as a squared plus b squared equals c squared. However, usually it makes more sense in geometry that we write c squared equals a squared plus b squared. Of course that's the same because it's equal either way, but it usually makes more sense because we're often solving for the hypotenuse. C is that hypotenuse that's across from the right angle. Thinking of a right angle like an arrow, it's pointing over here to the L. So it's L squared equals the A and the B are those two sides, so 9 squared plus 6 squared. So L squared equals 81 plus 36. Therefore, L squared equals 117. And when I try to solve for L by taking the square root of both sides, I remember that it could be positive or negative of the square root of 117. However, because L is the length of a side, we're only going to take the positive square root of 117. Now I could type this in my calculator, but it's irrational and going to give me an answer I have to round, and I'm not finished with my problem. So when we go to plug it in here, we're going to leave it as square root of 117. So now let's go back to our lateral area formula, and we can plug in the things that we found. Pi times the r is the radius that we computed earlier to be 6, and the L is what we just computed using our Pythagorean theorem, square root of 117. Now I'm going to go to my calculator, type it all in, and the lateral area is approximately 33.98, if we round to 2 decimal places, meters squared. Remember, area is 2 dimensions, so we have to use square meters. It also tells us in our problem that it's square meters. So there is our approximate lateral area of the cone. Second example, find the surface area of a pyramid that has a square base with sides of length 6 feet and a height of 4 feet. Here's the picture from our formula sheet of the square pyramid. Let's label it with the information they gave us. The square base has sides of length 6 feet. So the base is a square, so that means it's 6 along this side, 6 along this side, and 6 along all the other sides. It says the height is 4 feet. So instead of the h here, we can put 4. We need the surface area formula. So let's go to our formula sheet, find the pyramid, and look for SA. Here's the formula that we need. Let's go back to our problem and write that down. The surface area equals 1/2 LP plus uppercase B. It very much matters that we write uppercase B because uppercase B, remember from our formula sheet, means area of base. Lowercase b just means the length of the base. So there are some things that we have to find first in order to solve this with the formula. L is not given in the problem. P, the perimeter of the base, is not given. And uppercase B, the area of the base, is not given. So there are some things we have to find first. Let's start with the L. So remember that the slant height can be found by looking at this right triangle and using our Pythagorean theorem. The height is 4. The base of the triangle, well, it's not given, but if this all the way across is 6, this triangle starts at the center and goes to the edge, so that's half of 6. So that's going to be 3. So recall in our Pythagorean theorem, I'm going to draw this triangle separately, where we've got 4 on this side, 3 on this side, and this is L. We can use the c squared equals a squared plus b squared, where c is the hypotenuse. So L squared equals 3 squared plus 4 squared. We're adding these, so it doesn't really matter if we say 4 squared plus 3 squared or this way. Therefore, L squared is 9 plus 16, which makes L squared equal to 25. And then when we're trying to make the squared go away, we will say that L is plus or minus the square root of 25. But because this is a length, we're only going to take the positive answer. Square root of 25 does come out to a whole number, so I'll write it as positive 5. So we found the slant height, the L. Now we know that it's 5. We also need the P, the perimeter of the base. Now the base is a square, so again we can go back to our formula sheet if we're not sure how to find it, and recall that for a square, the perimeter is 4 times S. What's S? The length of the side. So back to our problem, let's write down that P equals 4S. And because this is the length of the side, that's the S, 6. So P equals 4 times 6. So P is 24. Next, we need uppercase B. B is the area of the base. So back to our formula sheet. For a square, the area of the square is S squared. So back to our problem, the area of the base is S squared. So the S we said is 6, so that's 6 squared. Therefore, B is 36. So again, you might want to remind yourself that B stands for area of the base, and the P stands for the perimeter of the base. Let's go ahead now and plug these values into our formula. Now that we have them all. L we found was 5, P 24, and B 36. Computing that, we get that the surface area is exactly 96 because the units are feet and we're finding area. Area is 2 dimensions, so it's going to be feet squared or square feet. There is our surface area.